Back then, basically everything that FMI has property rights to open was opened. The data content is very vast. There are both real-time and historical observations and climatological data and weather forecasts models, several weather forecast models, marine forecast models, output data, and so on. And the data is provided in freely in machine-readable format. And actually, the data is provided in Inspire harmonized format. Because FMI Open Data Portal follows Inspire requirements, and actually we use the very same data portal for our Open Data Portal and Inspire Data Portal, Inspire Data Services. For view services, we use GeoServer. We are actually planning to change that to SmartMet server, which I'm talking more quite soon. But back then, when we was implementing our portal, we didn't have WMS interface in a SmartMet server. For catalog service, we use GeoNetwork. And for download service, we use this SmartMet server. We use Web Feature Service 2.0 simple profile. So this means we use stored queries, predefined datasets with some additional parameters. We have found this most convenient way for our users and also most efficient way to provide the data from huge amounts of data. Okay, that's about open data. That's about background. Then into the SmartMet server itself. In a nutshell, it's a data and product server for all kind of MetOcean data. It's designed to provide high capacity and high availability. For example, our installation handles every day over 30 million requests. And we provide very high availability services like aviation services with this server. It's designed in a way that data is extracted and all the products are generated always on demand. We practically do no work before someone actually requests the data or the products. And of course we cache everything very aggressively. The server is Inspire compliant if it's configured so, and it's been operative. It's been operative since 2008, almost 10 years. First it was used for FMI client services, and since 2013 it's used for our Open Data Portal and Inspire Data Services, and it's going to be used also in Copernicus contexts in Climate Data Store. The server is open source and it's published in GitHub. More about that later. The server can handle several input sources. Most importantly for our domain, it can utilize script and netcdf files, which is our main data formats. At the moment, unfortunately, we have to convert the data into internal data format. We are going to get rid of that, but at the moment we need this intermediate format. The server can also be connected to PostGIS database for vectors and other SQL databases for point observations. For output, there are several interfaces and formats available. Most important ones are WMS, WFS. WCS is also available. We are not using that very much at the moment, but it's available and there are some implementations running. And for output formats, XML and JSON are by far the most important ones, but there are other ASCII formats as well, and then it can also extract data in binary formats, CRIP1, CRIP2 and netcdf. As I mentioned, we use this for Inspire Data Services and an Open Data Portal and also our client services, but we also use the server as a backend for our mobile applications and public web pages, and we have also integrated the data server into many of our client systems directly. The server is open source. It's published in GitHub quite recently, in late 2016. It's published under MIT license, so it's very open license. And the documentation is in GitHub as well. FMI use the server and host the development, but we welcome very warmly all usage and especially contributions. Small contributions can be done with just pull requests, and for larger contributions we recommend an implementation plan in Wiki as a public plan, so that we can discuss about the plan before it's implemented. And one note that CLA is required in order to contribute. To the technology, the server can be run in a single node where there's just one server, or in a clustered mode where there's front ends and backends. Backends are the server nodes which provides actual services, APIs for our clients, and front ends provides load balancing features, and they have a knowledge about backend services. And in the front ends there are also very efficient product cache. The server code is plugin based. It consists of engines which provides shared access to the data, and plugins which provides actual services, APIs, built upon those engines. To mention few engines, there are query data engine which handles the grid data, and then there's observation engines to handle point data, and then there's a number of geolocation information for location names and other GIS data. Most important plugins are WMS, which generates SVG images from grid data on demand, and those SVG images can then be rendered to the requested raster format if needed. WFS provides a point data output for grid data and observations, and then there's a time series which provides a custom point data interface with the support for aggregate values over time and area. For binary data, there are download plugin and WCS plugin, which provides mostly the same functionality. WCS is standard interface and download plugin is a custom interface. The server has also some post-processing capabilities. For example, it can correct the data based on accurate DEM model with up to 30 meters resolution and land and water information. In this example image, temperature is corrected based on a difference between model topography and actual topography. And this is a very great example of what we can achieve when we are doing things on demand, because we couldn't possibly do this kind of processing if we had to save the result into file system with this kind of resolution. The server can also calculate some derivative parameters like maximum, minimum, trend, and so on. Derivative parameters like feels like, sunset, day length, and so on. And it has a support for aggregate values over time and area, like sum and mean and trend and so on. Okay, one concrete example. We have, for example, our forecast data and model data on NFS. SmartMet server Q engine memory maps the data and provides a logic for interpolation for the data for requested area and time. And then WFS plugin does the on-the-fly formatting based on the template and provides Inspire-compliant XML responses. This response could also be formatted to JSON or any other format, just based on user requests. Okay, I don't have time to go through these, but our setup at the moment, we have 2 front ends, 7 backends. As you can see, backend servers are quite modest, typical off-the-shelf servers. Front ends are else quite modest servers, but they have quite lots of RAM to provide this product cache, in-memory product cache. It can also utilize disk, but in-memory cache is of course much faster. With this kind of setup, we can achieve quite good performance. Our typical load is over 30 million requests each day. Our busiest day have been over 80 million requests per day. And actually during few hours, it was a storm case quite recently in Finland. This means that our baseline is about 200 requests per second and peaks over 650 requests per second. And average response times are on the right side for WFS and WMS, little over 100 milliseconds per request. And for time series, which is custom JSON form interface, there are 30 milliseconds per request. Autocomplete is a plugin to provide geolocation services, and they are very fast. We have done also some load tests with 5 servers, and we have generated a scenario based on our operative use from access logs. We have achieved with 5 servers peaks over 4,300 requests per second, and during those peaks 95% of requests was still responded quite fast. It's notable that our operative use consists of very light requests, 1 time series for single location, but one can also do a very heavy request with lots of data and lots of processing. And because of this, we need independent queues for slow and fast queries, so that fast queries are not affected by slow ones. Okay, that's where we are now, where we are going to. As I mentioned, at the moment we have to convert all the data into internal data format. This is a major shortcoming or handicap. We need to support these data formats natively, and we are quite far. At the moment we can support grep files, we can get time series and data out from grep files, and we are converting our plugins to use the new engine, data engine, and after that we need similar driver for netcdf as well, and probably some HDF5 formats. And then we would like to provide a clustering support over internet, because our datasets are huge. It's very hard to move the data around the world. It takes time, and data gets old when we have actually got the data home. We would like to provide the services where the data is located originally, but we would still like to provide a single API for our client, so that backends are separated in many places, but clients have still a single API, and client doesn't have to think about where the data is actually located. Okay, that's all. I think that was quite fast. No, I wasn't.
Thank you very much. I think we have time for 1 or 2 questions.
I missed the beginning of the session, but yes, hello. I was wondering, do you already have other people that use the Met server or this software, other than your organization?
It's used in at the moment. It's used in Copernicus, or it's in Copernicus CDS Climate Data Store Service, which is not in operational phase yet, but it's going to be used there. It's going to be also installed in some other countries' national meteorological services, but I think we are at the moment only operational user. It was published in late 2016, so this is open source issue is quite new.
I have myself. So I have also a question. You mentioned several times Inspire compliant. So have you tested? So what validator did you use to check whether the services are compliant?
We have tested against old validator, and we have tried to test against the new validator, but unfortunately on the GML basic test was the only one we was able to run against new validator. To be honest, the old validator gives some errors. It's not all green, no, not at all, but in my view, the problems at the moment are not so critical. They are just configuration problems, not the server itself.
Okay, as you know, we launched a new version of the reference validator now, and we are seeking a feedback. So it would be very nice if you can provide your feedback from using the validator software with your services. That would be very useful to get your feedback on.
Yeah, we will.
Okay. Okay, so thank you very much once again.
Thank you.
So now we're moving to geology, and the first presentation will be my honor to invite my former colleague Lucia Ondrová, and she's going to tell us something about how they are trying to make geophysical data inspire. Lucy, the floor is yours.
Okay, thank you, Robert. Just a second. Hi, everyone. My name is Lucia Kondrová, and I'm working at the Czech Geological Survey at the Division of Informatics. And I must admit that from this team of people, I'm probably the least competent to present because I'm not a geophysicist, but I'll try to introduce the work that mostly they have done, but I will try my best. I will first touch on the Czech Geo epos and introduce what we mean by that. Then I will explain how we understand the geophysical data as it is specified in Inspire. And then I will try to present the current status of how we are providing and maintaining geophysical data at CGS and our future plans. Czech Geo epos is a system of geophysical observations performed by 8 geoscientific institutions in the Czech Republic. These include Czech Geological Survey, Czech Geophysical Institute, universities, and etc. It is closely related with the EPOS project because it provides data for EPOS. It's been functional since 2010, and CGS is member of Czech Geo since 2014. Czech Geo provides on one side data in real time. These include permanent observatories that are involved in global networks, as well as local and mobile stations for repeated field measurements. These are performed by 7 geoscientific institutions. As I mentioned, the Institute of Geophysics of the Czech Academy of Sciences, Faculty of Science of the Charles University, then Masaryk University of Brno, etc. And also CzechGeo includes data from geological mapping and research and archival data, which are held by Czech Geological Survey, are included in the geological and geophysical databases and file systems, as I will mention later. Of course, all this information is essential for performing basic and applied research in the Czech Republic, namely for geological mapping, prediction and mitigation of landslides, tectonic research. This is used mostly for storage of CO2, radioactive waste in the recent years, and so on. Geophysical data are included in SPIRE in the theme Geology in the Annex 2, and it includes core data model and a possible extension. CGS organized a small international workshop in June 2017 in cooperation with Hungarian and Danish Geological Survey and Italian National Institute on Oceanography and Applied Geophysics or something like that. And we were just discussing how to understand the data specification and how to provide the data. The core data model, from our point of view, includes two main feature types. This is not an extensive list, but what we see as the most important. It's a campaign and geophysical measurement. A campaign is an activity that provides the measurements, and the measurements can be of type geophysical station, geophysical profile, and geophysical swath. The extension adds additional feature types that can be provided. For example, project, that is a larger activity that can contain many campaigns. A generic geophysical measurement, which adds some additional methods that are not included in the core data model, and geophysical model as the result of some processing or interpretation of data. The model can be in a form of curve model, surface grid model, solid grid model, or other geophysical model. As you can see, the data model is not very simple. This is how we see it. We are focusing first, of course, on the core data model, and then we are moving to the extension and maybe also to relate the data to observations and measurements and provide some more descriptions to sampling features. What we see that should be provided in the framework of CzechGeo project as INSPIRE data are these data sets: geophysical monitoring stations, borehole geophysics, airborne geophysics, ground geophysics with several methods, and background geological data, of course. Not all of these data are maintained by Czech Geological Survey, of course. We only have very little subset of this data. We identified last year approximately 20 main data sets from our databases or file systems that are in current status are provided in different forms. And this year we are focusing on their metadata description, analysis of the INSPIRE code list, and initiation of data harmonization process. For the campaigns, we would like to have a first draft version of INSPIRE harmonized dataset this year, until the end of the year. And for the measurements, we hope to have the first version of well logging dataset for testing until the end of this year. This is just an overview of the measurement datasets that I'm talking about. The yellow ones are the datasets that are included in the core data model, and the green ones are from the extension. As I mentioned, the form of the geophysical data at Geological Survey is very different regarding either the form of information or the content. The form is either structured or unstructured or a document in a paper format, for example. And regarding the content, we have primary data, the measured data, or somehow processed data derived, and overview data, which should be explained as the campaign, like the overview of the measurements. As you can see, most of our data sets are available as unstructured at the moment, so a lot of consolidation needs to be done before we can provide this data as harmonized services. This is just to give you some statistics on the current status of centrally stored geophysical data. This is from our metadata catalog, because everything that is in the central data store is described by metadata. We identified approximately 35 public records, and approximately 1/3 of these data sources are structured, by which I mean that are stored in an Oracle database or ArcSDE database. And 2/3 of these data are unstructured in some file systems. Mostly these are the data that we inherited from the former state-owned enterprise Geophysics Brno. So it was a large amount of data. To some of these data, we already have some public access via applications. This is the current status. You don't see much of the pictures, but anyway, we have some map apps for geophysical surveys, seismic profiles, and well logging. And now we are working on the vertical electrical sounding. And we have a database app for unpublished reports, which is archival system. Here are examples of, on the left picture, we have our classification system of the geoscientific themes and what we have included so far under geophysics. And these are the WMS services that we are now providing. This is how we expect to implement INSPIRE. We are now in the phase of analysis of available data. Then we will move to mapping current structures to INSPIRE, which will definitely include simple transformations of data that are similar to INSPIRE, but also some very complex changes to structures and different data transformations. We hope to be automated transformations in the future. And also we will definitely have to manually add some data, some information to our current data. And then we could move to provision of web services for harmonized data. With regards to the whole CzechGeo project, we are now in the phase of consolidation of our data, like the CGS data. We would like to provide harmonized data sets for measurements in 2018 and 2019 for the seismic profiles, vertical electrical sounding, vertical seismic profiling, and others. And then it also means for us that we would have to deal with geophysical data from other providers in the Czech Republic who are not very well aware of INSPIRE, I think. So we are going to hold some workshops for them. First one will be in September, in 2 weeks' time, on metadata. And then we will have to analyze what's available in the Czech Republic for geophysics, and then work with the providers on provision of web services. And we hope to promote more the data from the Czech Republic on the European level. For example, in EGDI portal, I just have a simple picture of how it looks like. I don't know if you're familiar with it. And here is what you can get if you are looking for geophysics. You can select in the map window the geophysics theme, or you can go to the metadata catalog and simply search for geophysics and you will get much more records, because not for all of the records we have map services, of course. So thank you for your attention.
Okay, thank you very much, Lucy. Are there any questions, please?
Geophysical data provide somehow 3D data about the structure. Geophysical data provide 3D data about the structure of the underground. At the moment, we can only see that there are data, but you don't have anything intention and any idea of how in the future somehow these 3D data results themselves will be introduced to Inspire.
I must admit that we don't have yet any certain idea, but we are thinking about it, but not anything I could present.
Okay, any other question to Lucy? I have a question regarding, you mentioned that you had a workshop with other countries. So does it mean that the approach that you presented is also followed by the other countries? Especially in the field of kind of harmonizing the attributes that are required, or the interpretation of the model that is in the technical guidelines?
Well, it was, on one hand, it was meant mainly for us to more understand the data specification, because the Hungarians were one of the authors of the data specification. But also we discussed that some code lists are not perfect and will have to be somehow extended or modified. So I'm expecting we were talking about making a working group or something and work on extension of a code list. So I hope there will be a common approach with the other surveys.
Okay, thank you. I would just encourage to use the Inspire thematic clusters, the geophysical subgroup that is there, to share, your discussion and information, and in order then to harmonize the approach, with others. Okay, so if there is no other question, still have time? No? So then we move to another presentation that will be done by Michael Beaufils.
Michael Beaufils, indeed.
Sorry, I'm sorry for the pronunciation. And he's going to tell us their experience in implementing Inspire in the French Geological Survey.
Yes. So, good afternoon, everyone. My name is Michael Beaufils. I work for the French Geological Survey, as known as BRGM, and this is a presentation about implementing Inspire as a BRGM world trip. So, for people that don't know what is BRGM, this is French Geological Survey. It's about 1,000 people in 5 main departments, and what I can say is BRGM is an historical and active contributor for integrity geoscience. So we are working on several. We are part of the OGC and CGI. We also work on several projects that aim to enable geoscience data interoperability and even lead some of them. So, what we try to do as a Geological Survey, what people in Geological Survey try to do is, I think it's understanding the subsurface. So it starts with one man or one woman that is asking himself about how geology is on part of the earth. So, he first may think that geology is made with some geological units, some aquifers, some geological structures, so on, and he may want to have more information about this. So, to have more information about how the several features are work and how it is structured, he may have some what I call some human action. So he may have some observation campaign, drill some boreholes, and set some environmental monitoring facilities. And this action will enable him to gather some evidences, such as borehole logs, such as georesource resource, water occurrence or oil occurrence, something like that, and geophysics that we mentioned just before. And well, most of the time it enabled him to have a kind of interpretation of how geology works at this place. And he can build some models. And those models will enable him to predict that what should we have if we drill a borehole here, and we have some special representation with virtual logs and maybe maps, geological maps. And it can also provide some expected evolution, especially for groundwater metering, if we have some these new incomes that, well, this will be like that. So basically what we try to do at BRGM is to have a kind of big IT systems that enable to handle all of these features, all of these observation, all of these links between all source data. So to fulfill that use case, well, we're of course working on serving data through interoperable web services in conformance with Inspire, of course. We're also working on linking data through the referenceable persistent identifiers and providing tools to work with those data. So last year we have a presentation that explain how we do this. It's what we call the BRGM cocktail. So it's basically made of WFS app schema, source, identifier, and resolver. And what we have done is also providing clients. So today and for this presentation, we offer you what we call the road trip. So as far as, well, setting Inspire for implementing Inspire is quite a journey, so we offer you the opportunity to accompany us toward what we do with app schema and source and link data, and what we do with our GMLIS toolbox. So as for WFS app schema to provide features, well, the first thing that you have to know is that we tested a lot of several implementations, and basically at the beginning of 2017, we made a decision to use GeoServer in app schema extension and to contribute to its enhancement. In fact, basically what we done at the moment is we just installed GeoServer, but we didn't really contribute to its enhancement, and we will maybe do this in the next time. So as for the feedback, well, these are some things we would like to be solved in GeoServer. I won't enter into detailing this, especially for people that are not familiar with implementing standards. But, well, as you may know, that, well, we made a decision that we call off the search for the perfect tool, and it was no time to work with what we have, and the best candidate were GeoServer, and we try to go ahead and implement it and maybe support the community. So that's what we made. And if you already implemented GeoServer and want to discuss about this, we can do it at this presentation. For SOS to provide observation measurement, the first thing I want to aware you is the existence of the D2.9 guidelines for the use of observation measurements and SUI in Inspire. So basically, it's very helpful for implementing Inspire for providing observation, and it was also very helpful for us because we had many feedback about how to do this. So as far as implementation of source, it was a bit different as for GeoServer, because we focus on 52 node solution, and we've entered into a kind of partnership with 52 nodes, and we first take their tool, and then they made some enhancements because we financed those enhancements and to fill our requirements, in fact. So as for now, we have one web app which is deployed per observation property. So we are able to provide some groundwater levels and also geologic logs according to groundwater ML specification. So here is another feedback that things we would like to be enhanced, but as I won't enter into in discussion about this. As for the identifiers in linked data, so the idea we had is, well, persistent identifiers on observation domain features as the glue in the proper system. And the core idea is to put a URI as a first-class element instead of the OGC get feature get observation request. So as you can see, we got, well, this URI which is a one-line URI that stands for this three-line URI, and it basically does the same, but the way it is done is with Apache mode rewrite to translate the URI in geodesy service request. So this is something that is to us too often overlooked in Spire discussion. We just have discussion about should it resolve, shall it resolve, and we do things that it should resolve. So as for now, well, these are the features and observation we can provide through our system. So the core feature is, as you can see at the middle, this is a borehole. This is the core thing I think Geological survey provide, and those boreholes can have some geologic description. And we also provide them, and they can be linked to also environmental monitoring facility, especially for groundwater monitoring. So we also provide them, and we also provide the links between observation features, and observation, and also other observations. So as you can see, the dashed line are the part of that are planned to be developed, but not yet developed. To show how we can use it, BRGM found with the European Environment Agency, Copernicus, found what we call the GMLIS suite. So there is the converter, where this is a part of the GDAL, and it offers converting functionalities developed to handle complex features. For example, we can convert GML app schema files in PostGIS and SQLite formats. And we also funded development for what we call the toolbox, which in fact is a client, and a plugin for QGIS. And if you want to test it, it's available through the Geo4W. And also you get information about how to use it onto GitHub. I will just show you basically how it works. So on the left part, you got the interface of QGIS. For example, you got, well, a borehole that has been drilled next to Lyon. Here is on the right part, you got the description of this borehole. This is also the description you can have if you get it via a browser. But in fact, what is important is the way we filled the information. For example, you got the purpose, and we provide links to the data dictionaries. So, and we do this for all the information we have. To show you the benefits of it, so here you can see we have, for example, a geologic description. It's the bottom part. And we know that this borehole has a geologic description. And the idea is, thanks to this tool and thanks of the elements that have been set and in the description of the data, we are able to go through and request more information about this borehole logs. So here is when you click on the geologic description, you get the description of the logs. You can see that you have some raw earth material observations provided. So that's kind of lithology. And we also developed tools that enable to have representation of this log for human beings, in fact. But this is, don't focus on the representation, the color of that video. It's not compliant with any dictionary. So, but you can imagine what we can do with that tool. So the BRGM perspective, as for now, we will continue implementing more and more feature types with the current solution we identified as the best one as for now. So GeoNetwork for CSW, Map Server for WMS, GeoServer for WFS schema, and 52 solution for source. Yet we also continue exploring new reasons and contribute in financing technologies improvements. So we got our GMLIS toolbox, but can be enhanced. We will also look at providing some GeoServer connection to a solar index in order to handle huge volumes of data, especially for the EPOS project. We also have a look at PubSub to notify users of updates in the systems. And Sensor Things approach to facilitate sensor data integration. So that's the plans for BRGM. As a conclusion, what we can tell you is that, well, for us, building an information system is not a one-time process. So I think we should not wait for the perfect tool and find, because I think it does not exist. But what we found is in searching for the perfect tool. So is some labs help testing things and get feedback from users. So it's very important for us too. And as far as users participating, building the system, it also helps getting their support. So it's also prepare them for the changes that will come. Of course, technologies need improvements, yet a lot of things has already been done. And what I can tell you is that I think that technology providers are willing to help. They really do. But we have to feed their efforts, providing them use cases, feedback, and maybe finance developments. So the idea I have, as far as, especially because this is a geoscience session, we have common needs, and why don't we build a common solution? So in order to share the efforts, make things going faster. So we propose that's kind of what we call the marketplace that have been also proposed during the FOSS4G last time, and also in the workshop yesterday. So the idea is to have kind of forum and in which people can say, well, I have some needs about free open software, and this will enable to connect people. We have also on the other part that some solution providers that can see that, well, this should be very interesting. We can build a market, and we should go for developing this. So I think it's something we can develop and will be very useful. As we are talking about a forum, I can't finish this presentation. We are speaking about an initiative called the Geoscience Domain Working Group that have just been set to push geoscience data interoperability. So the Geoscience Domain Working Group is co-chaired by UGC and CGI. And we will have first meeting next week, in fact, in Southampton, OGCTC. And we will have some discussion about what to do with borehole description, 3D geological modeling, urban geology, and geotechnics, which are very hot topics for now. And, well, just if you want to contribute, just join us, and it will be a pleasure for us to build interoperability for the geoscience. So, thanks for your attention.
Thank you very much. Any questions to Michael? No question.
It was perfectly clear.
Was it clear? I have a provocative question. So when we will have a European data sets of boreholes, at least the locations and the basic information?
In fact, well, I can't speak about what is done during the EPOS project. In fact, there is an initiative for it to have the kind of abstract view, abstract description of boreholes, and also we done especially with BRGM and also with Czech Republic. So basically, well, we will build from this experience. We hope that the borehole view description is already enabled, and you can have it if you request the EPOS servers. And the only thing we have to do is to call all the participants from other countries to do the same. I think would be a first step to have this.
Okay, thank you very much. I just have a comment that, I've seen a lot of those beautiful national developments, or let's say the organizational development, because basically you were presenting how you organize your data inside the BRGM. So this community is very strong and very mature, but at European level, or for instance at the Inspire Geo portal, we are lacking the geological and related data sets.
Yeah, I think that's one main reason for what we need a common approach and maybe a common solution that, for example, BRGM can start building and other people can contribute to have their tools. So it will, level down their contribution, but they will have the same tool as others. So.
Okay, so one.
Yeah, just to complement on. Yes, thank you, Robert. Just to complement on your feedback regarding EPOS and etc. What is interesting is that EPOS is not only a research project like classical H2020 project. That's a research infrastructure. That is meant to last. So far, the content of the borehole index we have contains French, English colleagues. Boreholes are about to come in some days. Team is nodding. We have already Danish, Italian colleagues, and some also academic partners like the University of Uppsala, GFZ content, and others are progressively coming, Czech Republic as well, and etc. So there are discussions for other surveys that are not officially initially part of the research infrastructure implementation project itself, but progressively joining the dynamic. And given that we're building on interoperability standard, not going against Inspire specs and etc., we should be, I'm confident we will enrich the content. We already have more like 3 million entries, so, well, just a little bit.
Thank you. And I would like to invite the last speaker, Mark Philip Wichmann.
Yes, exactly. Yeah, thanks.
And he's going to share his and his colleagues' experience with making the Inspire compliant geological map of Germany at the scale 1 to 1 million.
Yes, okay. Oh, 16, yeah, just a second. Yes. Yeah, it's all right, yeah, yep. And that's my one, yeah. Okay. Okay, fine. Okay, I welcome every one of you to the last presentation of our late afternoon session here, and I'm pleased to give a talk. Can you hear me? That's better? Okay, yeah, perfect, thanks. And I welcome every one of you to my talk about the Inspire compliant geological map of Germany at a scale of 1 to 1 million, briefly called GK1000. And as you can see here, I'm not the only one who worked on this topic. I'm representing here a team of 4 people at the BGR, and this team called the Inspire project team. And first of all, I will give you a short overview. I will give you a structure of my talk. First of all, I will talk about briefly about the content of the GK1000. The second step is the semantic mapping, and after the semantic mapping I will talk about the technical transformation, and then there's one part about the provision of the Inspire compliant GK1000 via a download service, and afterwards I talk about the provision of the Inspire compliant GK1000 via Inspire View service, WMS, and via the BGR GeoViewer. And finally, I will have some remarks on the visualization according to the Inspire portrayal rules. So let's start with the content of the GK1000. The GK1000 represents the surface geology of Germany and the adjacent areas of the neighboring countries. It comprises information on the lithology, the stratigraphy, and the genesis, and these three parts build up the geological units in this geological map, and it comprises also information on the faults and the marginal position of the ice shield. Before we can start with the semantic mapping, of course, it's clearly that we have to look what kind of data specification do we have to use for the transformation of this map to Inspire. And in this case, it's pretty obvious. We have to use the data specification on geology. And after this, we can start with the real semantic mapping. And in our case, the semantic mapping is comprises three steps. The first one is the mapping on class level. That means it's necessary that we identify the relevant classes in the GK1000 source model and in the Inspire target model. Here you can see a UML overview class diagram of the Inspire geology core model, and the red classes represent the GK1000 classes, and they are mapped to the corresponding classes in the geology core model. So this is the first step on the mapping on the class level. The second step of the semantic mapping represents the mapping on attribute level. So we have to define mapping routes. Here you can see an example for the class Genesis, for the GK1000 class Genesis, and for the GK1000 class Stratigraphy. Both held only one attribute. In the first case, it's the attribute Genesis, and the second case, it's the attribute Stratigraphy. And on the right side, you see the corresponding class geological event. So in the case of the GK1000 attribute Genesis, we have to map this attribute, or the values of this attribute, to the two Inspire attributes event environment on one side, and on the other side we have to use the Inspire attribute event process. And the same happens also in the case of the GK1000 class or attribute stratigraphy. We have to map this attribute, or the values of this attribute on the Inspire attributes older name age and younger name age. So in this case we are finished with the second semantic mapping on attribute level, and the third and the last one would be the mapping on code list level. So we have to translate, respectively, we have to map the code list value, in this case, of the lithology. On the left side, you see a detail of the UML geology core model of Inspire. You can see the attribute material, and for this Inspire attribute we have the lithology value list, which you can see on the right side, or a detail on the right side. And in this case we have to map our GK1000 code list values to the corresponding code list values of the lithology value Inspire list. So this is also an example, and as you can see here, what happens quite often, we have a generalization. In the case of the code values fine sand, middle sand, and coarse grain sand, all the attributes, or all these values, we have to map to the Inspire value sand, because we have only sand. I mean, maybe all the people here in the auditorium who are interested in the geology data specification maybe have also had this discussion before, why we have only sand, but in the end we have only sand, so we have to map these three GK1000 attributes to the one code value sand. In the case of kalkstein limestone, it's pretty easy. We have a mapping 1-to-1. Okay, so this is everything which I have to say about the semantic mappings. Here in the end, I will show you just one of our mapping tables which we use. So it's a mapping table in Excel, On the left side, you can see the GK1000 attribute and code list values, and on the right side, we have the Inspire attributes and code list values. And this kind of mapping table we will use later in the process of the technical transformation. Okay, so the semantic mapping is done, so we can start with our technical transformation of the GK1000. And the technical transformation I will explain to you as an example of the geologic units. We have a workflow, and this workflow comprises 7 general or main steps. The first step represents the input of our source data, including the mapping tables, which I have shown you before, the example for the lithology. The second step is the generation of a distinct Inspire idea for every geologic unit. That's the second step. The third step represents the attribute mapping and also the creation of attributes or of Inspire attributes, which are obligatory but which are not present in our source data or in our source data model. The fourth step is the reprojection of the geometry if it's necessary. In this case of the GK1000 it wasn't necessary, but in other cases it is necessary. The next step is the transformation of the geometry to the XML geometry in the target model, and the next one will be the output of the GML file. And for the output of the GML file, I have an example. You can see here on the left side, you can see a detail of the FME workbench just to get an idea how it looks like. Here you can see one of the transformers which we use, and on the right side you can see a detail of the GML file. And as you can see here, it's a detail of the FME workbench. So at the BGR in Hanover, we decided to use the FME, the feature manipulation engine, to do the technical transformation. And we not only use the FME, we also use the Inspire Solution Pack 2.0 by Contara, so that we can do all the technical transformation which is necessary to get in the end the GML output file. And this represents the last step of our workflow. Exactly, it's not the last, was the last one, but also we have to validate our GML file, and the validation of our GML file we do also with the FME. So we validate against the online Inspire schema, and if everything is okay, we're happy, we can say, okay, we have an Inspire compliant GML file of the, in this case, of the geologic units. So at this point, we also can say the technical transformation is done, and we can go on. And in this case, I will represent you at this step. We're coming to the provision of the Inspire compliant GK1000 via a download service. So there are different possibilities to use or uses of a download service, and at BGR we decided to use the atom feed technology. So because at the moment we're not able to provide a WFS, so we said, okay, we do it via the GML download, via the atom feed technology. And actually it's quite simple. I think most of you or all of you know the atom feed technology by newsletter of your favorite newspaper, etc. So this is an example, how does it work? So you can integrate this technology in your browser, and then you can pick different data from the BGR. In this case, the red arrow indicates Inspire compliant GK1000 GML file, and you can click on this, and then you can download a GK1000 Inspire zip file. And this zip file comprises 3 GML files, one for the geologic structure, one for the geologic unit, and a third one for the natural geomorphologic feature that represents the marginal the margin of the ice shield. And also at the bottom you can see this file. We have a README data, and the README data comprises information. So we have the metadata, and you have also an explanation in German and in English on the structure of the GML file. So what we did, you can read it there. And of course, in the end, we have also a PDF of the general standard terms and conditions, also in English and also in German. Yeah, we have to do it. So this is everything what you get when you download the GK1000 zip file. Okay, so at this point, the download service is also provided, so we can go to the next step. So we can talk about the provision of the Inspire compliant GK1000 via Inspire View Service, via WMS. This is also obligatory. So the user can use, in this case, our BGR product center. So you can go there, and then you can search for the Inspire WMS for the view service. And in this case, here you can get the URL. And then you take the URL, you integrate the URL in your own GIS software. This is an example for our GIS map or desktop. And then you can take a look on the contents of the Inspire compliant GK1000. In this case, you can see the geologic units according to the portrayal views for the stratigraphy. And on the second one, you have also, the possibility to get the GK1000 geologic units portrayed according to the portrayal rules for the lithology. And in both cases, you also have the possibility to use the Get Feature Info button, so you can click on the polygons or on the geologic units, and then you get all the information. So you get the information on the lithology, on the age, on the event environment, and also on the event process. I think normally it's not obligatory according to Inspire, but we thought, okay, if you just get the GK1000 map in color, or in the color of the stratigraphy and the lithology, that doesn't make any sense. So we decided that we also deliver all the information which you really need when you download the GK1000 or integrate this Inspire compliant map into your GIS software. Okay, so at this point also the web map service is provided, so we can go on. And in this case, this is like, we can call it an extra. We also provide the Inspire compliant GK1000 via our own Geos viewer, so via our own BGR Geo viewer. And in this case, you have also the same possibilities, like if you would integrate the WMS in your own GIS software. So you get information on the stratigraphy, lithology, etc. So also at this point, additional access is provided by us. And at the end, I would like to talk about a little bit about the visualization according to Inspire portrayal rules. In this case, here you can see also the example stratigraphy, and normally you don't have only one value for the age. Normally you have a time span. Like in this case, you have the time span Paleogene to Neogene, but actually you can only pick one color. So we decided, or we defined, that in this case, if we have a time span, we use the color of the older boundary of the age of the event. So in this case, we take the color for the Paleogene because we don't have any mixed colors. The same happens in the case of the lithology. And in this case, the majority principle applies. So normally, sometimes you have one lithology, one part. So it's quite easy. If you have only basalt, okay, you take the color for the basalt or the color for a term which is in the hierarchy higher. But in the case when you have different components, like here you have basalt, tholeiitic basalt, bentonite, tephrite, fluorite, and andesite. So what do you do? So we decided that we use the majority principle. That means if we have more than one lithologic component, we use the term which comprises the majority of all the components. That's our solution, and I think that works pretty good. So this is one point which I would like to point it out about the visualization according to the INSPIRE portrayal rules. So let me please summarize. The geological map of Germany at a scale of 1 to 1 million, shortly called GK1000, is fully, respectively, it's the first fully INSPIRE compliant geodata product provided by the BGR. Maybe we can talk about this expression, what means fully inspired, compliant. I mean, as we heard today in the plenary session, I think one of the people, one of the politicians, was talking about I don't know how many he said, or I don't know the amount anymore, but it was like 32,000 geodata sets, and I thought, okay, they are all fully INSPIRE compliant. Actually, they are not. I mean, they are in the system, but we still have to wait for the whole transformation of these geodata sets. Okay, so all in all, we fulfilled all the legal requirements given by INSPIRE. That means we have transformed the content according to the data specification on geology. We are providing a download service, in this case via the atom feed technology as a GML download. We have an INSPIRE compliant web map service, and additionally we provide our INSPIRE compliant GK1000 via the BGR GeoViewer. But of course, you can not only have access via our BGR GeoViewer to the GK1000, also you have access via the geoportal.de. That means via on the national level. And in the end, of course, you find also, since a couple of months, INSPIRE compliant GK1000 in our INSPIRE geoportal on the international level, and that's a place where it have to be. Okay, in this sense, thank you very much for your attention.
Okay, thank you, Mark Philip.
Yeah, you're welcome.
Do we have any question to Mark? No questions. It was very clear, very nice. I should have some questions. So, you mentioned that you had an issue on simplifying or generalizing of the division of sand, different type of sands.
Yeah. Fine cost, middle cost.
You know that the chord lists that are, especially in the geological team, the majority are, or all of them are extensible. So the original idea is that you don't need to generalize. You extend, in the level of granularity,
yeah,
and then you provide your national extension to the chord list.
Yeah, I know, but actually, my point of view about the extension is, I see it a little bit critical, because if we, of course, as you said, we can make an extension and we say, okay, we have also fine-grained, middle-grained, coarse-grained sand, that's fine. But in the end, I mean, if all the other countries in Europe say, oh no, we don't want this extension, I mean, my point of view is, in this case, it wouldn't make any sense. So we need a compromise then also. Yeah? I'm not a fan of national extension code value list, actually.
Okay.
I mean, it's a possibility, but then, I mean, what means INSPIRE then in the end, if every country will do this in the future?
No, but we have something that we call the federation of the registries. So one of the requirements of any extension is that you are providing the access to those extensions to others, so that other people, when implementing, they will see that in Germany they have already did this extension, so therefore we will use it or not. So that there are some mechanisms. We have the the federation of the national registry. So if you go to the central INSPIRE registry system and chord list register, you will find the possibility to see these national extensions. So therefore you can really pick it, etc. So the concept is there.
Yeah.
I agree, it hasn't
But
been
I'm not so
fully...
convinced on this solution. I mean, maybe it's like the same problem which was Matthias talking about. Maybe we have to say, okay, since until 2020,
Yes.
the data specification on geology is like that, and hopefully most or all of the countries will provide their INSPIRE-compliant geodata set until this year, and then we can say, okay, and now we going on and we do a second version of the geology data specification, with fine-grained sand, for example.
I mean, I would agree that,
I would prefer that.
it's a matter of the community, that I
Yeah,
would
of course.
agree, and many other aspects that you said. For instance, the visualization, this is a typical example that is not regulated by the INSPIRE technical legal framework.
Yeah.
It's
Not
on
all.
purpose left to the communities to agree.
Yeah.
So this is one example. So your solution that you made the decision that, you know, in terms of the majority of lithology and etc.
Yeah, also like this, it's not.
No, but that
There's no
decision
any
is
regulation.
exactly
Yeah.
that decision is exactly a domain-specific decision that should be shared and ideally should be agreed inside the community, because this is how we keep the interoperability.
Yes, of course. I mean,
alive.
it's just one way, maybe. Yeah.
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 Yep, please.
Well, Mark has mentioned me. Robert, this is the point, and the objections that Mark had is, I think, goes very much to the point and to the core of the idea of INSPIRE. You can certainly extend with a specific register information, but at the end of the day, it's simply the fact that other countries can, if they want to have access to one country's special enhancement of the registry, is in a way allowing to work around the core of INSPIRE. That's what I want. You wanted there, but that was the idea of my presentation. This is a good example. I mean, there's nothing wrong with that. It's just the unification or the simplification is just that it misses information. And in my point of view, I couldn't see any objections why you should not make sand and then add fine coarse and fine middle and coarse sand to it, making it another hierarchical level. This is, as Mark said, not something for now, but this should be thought of or achieved in the main next step in INSPIRE, my point of view, and then making it available in what legal way soever as a part of the core element and the core content of INSPIRE. And in my point of view, if we want INSPIRE to be that what the plenary speaker this morning suggested to, I think this is the way to go.
Any comment or question to Mark Philip?
Yes, Mark, Dean from SAFE. I was just curious if you had any challenges around the transformations or assembly of the geometry for geology.
Okay, in this case, yeah, I forgot. We have also a poster presented by my colleague Stephanie Bellenberg, and I think in this case, I mean, we had a lot of challenges, to be honest. Yeah, I mean, we had a really good introduction to this topic by Contera and also Sören Ducke, but also then during the process, we have so many challenges. I can't remember how many we had actually. And can you tell us something about the geometry challenge? I think this was. I'm not the technical guy, so I'm sorry, but I think it worked pretty good, I would say.
GML structures, or was it more of the dimension, like multi-surfaces and the 3D aspect?
No, we didn't have any 3D aspects in this case, because we have only the surface geology, so that was, I would say, pretty easy. Yeah.
Or was it the INSPIRE structure?
What do you mean? Sorry.
Well, the geometry structure in INSPIRE, is that hard to map to based on what you had in the source data?
No, I think it was. Sorry. No, we didn't have any problems in this case. I mean, maybe we can talk about this later, but I don't remember. Sorry? There's a poster? Yeah, there's a poster with more details on the technical transformation. Because in this case, I can't put everything in the talk, so you're invited to take a look. Okay.
Okay. Last question. If not, then allow me two more comments. So
yeah, of course.
One is that the fact that on Friday at 1 o'clock, right?
Yeah, Kim? I heard about this. Yeah.
Yeah. At 1 o'clock, there is a meeting of the geology thematic cluster that will be organized by Tim Duffy over there and Carlo. Okay, and this is exactly the platform, and they will explain to you, this is exactly the platform where some of your decisions that you made during the transformation and creating the services and visualization should be at least shared, that other can, take use of it. Yeah. So it's Friday, 1 o'clock, and the meeting point is the Inspire stand. Okay, so this is one. What do you mean? It's still. Yeah, I mean.
No, but
I mean, this is not the only opportunity. This is not the only opportunity.
So, actually, some aspects which I have presented, I can send it also to you by an email, right?
No, exactly. So discuss it on Friday. And
yeah, because I have also the problem that Friday is actually too late for me. So I'm just asking.
If you have some questions, tomorrow I'm available.
Yeah, or maybe we can talk about this.
The cuff break, you can.
Yeah, okay, that's fine. Yeah. Yeah, that would be good. Especially about the get feature info, because there are no any regulations about the wording, etc. So
okay.
Yeah.
The other announcement which I already said today, so we have now the reference validator. So I would really welcome you to, to try to use it with your services.
We will do, yeah.
And then you can really say it's Inspire compliant. There is one warning that for the geology, the data set test hasn't been yet done. So there is a generic schema test, but there is no the content and the team specific requirements test yet. This is another topic maybe for the community to discuss, that you can work on together with us and interactive instruments on developing the executive tests specifically for geology. Okay, so now allow me to close the session. So I think we've heard a interesting presentation. So 3 from the domain of geology and geophysics, 1 about the very robust IT solution and in provision and processing of meteorological data. So I think that all presenters deserve our applause once again. And please enjoy the rest of the conference.